Okay, so good day everyone. So this time we're going to discuss about the linear regression, multivariate linear regression, gradient descent regularization. Okay, again, in this topic, we're going to focus on the complete guide to all the regression. No? So linear regression is the simplest and most widely used statistical technique for predictive modeling. So it basically gives us an equation where we have our features as independent variables on which our target variable is dependent upon. So to give us more details about the topic, let us all welcome our presenter. Go ahead, ma'am.
Discussing about linear regression, multivariate linear regression, gradient descent regularization. What is linear regression? Linear regression is a linear approach to modeling the relationship of more independent variables. Equation for linear regression is y equals a plus b multiplied by x, where x is the independent variable and y is the dependent variable. The slope of the line is b and a is the intercept value, the value of y when x is equals to 0. Simple linear regression. For example, suppose that the height was the only determinant of body weight. If we were to plot height, the independent or predictor variable, as a function of body weight, the dependent or outcome variable, we might see a very linear relationship as illustrated below. We have in the y-axis is the body weight in pounds and in the x-axis the height in inches. We could also describe this relationship with the equation for a line y a plus b multiplied by x, where a is the y-intercept and b is the slope of the line. We could also use the equation to predict weight if we knew an individual's height. In this example, if an individual was 70 inches tall, we have to predict his weight to be y is equals to a plus b multiplied by x. So, weight, which is y, and a is equals to 80 plus 2 multiplied by 70, which is x, 70 inches tall. So, we will have the weight to be 220 pounds. Multivariate linear regression. Multivariate linear regression is a technique used to measure the degree of which the various independent variable and various dependent variable are linearly related to each other. The relation is said to be linear due to the correlation between the variables. Once the multivariate regression is applied to the dataset, this method is then used to predict the behavior of the response variable based on its corresponding predictor variables. Characteristics of multivariate regression. Multivariate regression allows one to have different view of the relationship between various variables from all the possible angles. It helps you predict the behavior of the response variable depending on how the predictor variables move. It can be applied to various machine learning fields, economic, science, and medical research studies. Steps to achieve multivariate regression. select the features, normalize the feature. To change the value of each feature, we can use select loss function and formulate the A hypothesis. Minimize the cost and loss function. Test the hypothesis. Advantage and disadvantage of multivariate regression. Advantages. Methods help you to find a relationship between multiple variables or features. It also defines the correlation between independent variables and dependent variables. Disadvantages. Multivariate regression technique requires high-level mathematical calculations. It is complex. The output of multivariate regression model is difficult to analyze. The loss can use errors in the output. Multivariate regression yields better results when used with larger data sets rather than small ones. All the dependent variables starting from y1 up to yq are dependent on the same set of independent variable, which is x1 up to xp. For example, let us consider only one variable. Let us think that there are a set of p independent variables, which is x1, x2, up to xp. There will be several coefficients. Those are known as regression coefficient. So y1 is affected by x subscript 1 or x1. So we have the coefficient beta 1 from the dependent side and the other one is the x1 from the independent side. So we have beta 11. So same as in the second independent variable, which is x2. So beta 1 from the dependent side and 2 from the independent side. So up to the xp. So beta 1 from the dependent side and p from the independent side. So we also have a constant term of x0. Which will be beta 10. So beta 1 from the dependent side and 0 from the x0. So this x0 will always take a value of 1. So our equation will be y1 is equals to beta 10 plus beta 11 x1 plus beta 12 x2 plus up to beta 1p xp plus epsilon 1 or the error 1. So this will be our multilinear regression. So let's add another variable, dependent variable y2. Then if we want to know how they are affecting, then 2 beta 2 from the dependent variable is affected by the x1 from the independent variable. Same with the beta 2 from the dependent variable y2 affected by the independent variable x2. So it will become beta 22. Same with the last variable, which is xp. It will become beta 2 from the dependent variable y2 affected by the independent variable xp. So it will become a beta 2p. As the first dependent variable has also the constant term x equals 0, x0 will always take the value of 1. Then beta 2 from dependent variable y2 is also affected by the constant term x0, so it became beta 20. So there is also an error for our second dependent variable. So our equation will be y2 equals beta 20 plus beta 21 x1 plus beta 22 x2 up to beta 2pxp plus error 2. So this will be our multivariate linear regression or MVLR. So let's proceed to gradient descent regularization. What is gradient descent? It is an optimization algorithm to find minimum of a function. Start with a random point on the function and move in the negative direction of the gradient of the function to reach the local and global minima. We have example of gradient descent. So we have a function of y equals x plus 5 raised to 2 of 2x multiplied by x plus 5. Step 2. Move in the direction of the negative of the gradient. But how much to move? So for that, we define the learning rate. We have set it to 0.01, for example. Step 3. Perform 2 iterations for gradient descent. First is to initialize parameters. So we have x0 is equals to -3, and the gradient function equals to 2x multiplied by x plus 5, and the learning rate equals to 0.01. This is the -30792. This is the next point from the second iteration. So we have the second point of in the x-axis by step of 0.01. In order to reach the global minimum, we must perform more iterations, and we need to perform exactly the same action for each iterations to get more values on x-axis till we reach the global minimum value. In this example, we have the global minimum of x minus 5, and that's how the gradient descent works. So thank you.
Okay, so as what our presenter mentioned, no, again, it is important, of course, for us to understand the linear regression first, no, equation, no. So we have also what we call line of best fit, no. A line of best fit is a graph showing the general direction that a group of points seem to follow. So the main purpose of the line of best fit is that our predict value should be closer to the actual value, and the best fit line tends to minimize the difference between the values predicted and the actual values, no? Yung error or yung sinasabi natin na residue. So the residues are the vertical line extended from the residual line to the data points, no? And our main objective is to find out these errors and minimize it. So we can measure the residue in three ways. Number one, sum of residuals, sum of absolute value of residuals, and sum of square of residuals. And of course, therefore, sum of squares error is given wherein the predicted values, y is the actual value of the and m in the number of rows, no? And this is similar to sum of square error, hence it is also called mean squared error. For every model, we need to minimize the cost function. So this is done by using a gradient descent algorithm. Now, so what is, maybe you're asking, Doc, what is gradient descent algorithm? So gradient descent is used to minimize the error function by iteratively moving in the direction of steepest descent or yung pinaka-negative descent. It is used to update the parameter of our model. Suppose, if we want to find out the best parameters of of course, theta 1 and theta 2 for our linear regression algorithm, the gradient descent works by iteratively updating theta and find the points where the cost function is minimum, no? Actually, in evaluating the model of R squared, no, it determines how much of total variation is in Y, yung dependent variable, is explained by the variation in X for the independent variable, no? We have also what we call drawback of R squared, no? The drawback of adjusted R squared is that if we use a new dependent variable in the learner, the R squared increases or remain constant. So this does not tell whether we are increasing complexity or making it more accurate. No, the adjusted R squared is the modified form of R squared E that has been adjusted for the number of predictors in the model. No, and it incorporates model degree of freedom. No, so how about choosing the right parameters for your model? No, during a high dimension data, it would be inefficient to use all the columns in the regression model, since some of them might be imparting redundant information. There are two main ways of selecting the variables. Number one, of course, is the forward selection. No, in our previous subjects, no, or course, forward selection starts with the most significant predictor in the model and adds variable for each step. And another one, of course, is the backward elimination. So backward elimination starts with all predictors in the model and removes the least significant variable for each step. So selecting criteria can be set to any statistical measure like R square, T-stat, and others. No? So a while ago, our presenter also discussed about the bivariate, no, bias and bias of regression models, no, and I think somebody also continued discussion with regards to this. We have also a ridge regression, no. The key difference between these two is the penalty term, no. Yung ridge regression adds a squared magnitude of coefficient as a penalty term to the loss function. Okay, so we have the formula in getting all those things. That's what I mentioned. And we have also what we call elastic net regression. No, it combines the power of L1 and L2 regularization. No, so the elastic regression generally works well when we have a big data set. So consider that we had a bunch of correlated independent variables in a data set. Then elastic net will simply form a group of consisting of these correlated variables. Now, if any one of the variable of this group is a strong predictor, or many having a strong relationship, no, with a dependent variable, then we will include the entire group in the model building, because omitting other variables might result in losing some information in terms of interpretation ability, leading to a poor model performance. No? So I think that's it for this topic.